So welcome back, and the next topic is epsilon closure. So before going to epsilon closure, what's the need of this epsilon closure? So as already told you, so in the real world application we are using only DFA. So but for our comfort, we are writing NFA for some examples. We are writing NFA with epsilon for some examples according to our need. Why? Because drawing DFA is complicated, but drawing NFA or NFA with epsilon is simple. So first we're drawing like that, then you're converting it into again final DFA only. Right? While converting from NFA with epsilon to NFA, so we need to find out epsilon closure over there. So for that purpose, here you're going to learn the finding epsilon closure. But before finding epsilon closure, what is the definition of epsilon closure? So epsilon closure of P is a set of all states which are reachable from state P on epsilon transitions, such that epsilon closure of P is equal to P, where P belongs to Q. If that means, for example, Q naught, epsilon closure of Q naught is equal to Q naught by default, even if you don't have epsilon on that same state. Why? Because obviously, right? So from that state, you can reach to that state only without taking any input, right? So no need to take any input to move from that state to that state itself. That means you're not moving anywhere. You're staying in that state itself, right? So if there exists epsilon closure of P is equal to Q, and delta of Q comma epsilon is equal to R, then epsilon closure of P is equal to Q comma R. That means, so you have a path, like we'll take one example. That means Q naught on epsilon, it is going to Q1. So what I need to take if I want to find epsilon closure of Q naught, obviously self will become. So that state will become, and Q naught epsilon on epsilon where it is going, Q1. So actually I should stop here itself. But again, Q1 is also going to Q2 on same epsilon only. At that case, you can consider Q2 also. For example, instead of epsilon, if I have some other symbol A here, I cannot take Q2 here, right? That means if there is any indirect connection, so Q0 to Q1 is also reaching to Q0 using epsilon, I can add Q2 here. But if any other input symbol is there, I cannot consider Q2 here. So that is epsilon closure. Epsilon closure means set of all the states which are reachable from state P on epsilon transition while taking epsilon where you can move from that state. So one is default, that is that state itself, and other than that, whatever the other transitions are there, that you need to add here. See, so this is the example here, same previous example, A star, B star and C star. So first I need to find epsilon closure of Q naught. So epsilon closure of Q naught, first thing is that state itself, that means Q naught, and Q naught on epsilon, it is I can able to reach Q1, but Q1 on epsilon we have another path. In that case, what I need to take, I need to consider Q2 also. So epsilon closure of Q naught is Q naught, Q1, Q2, and epsilon closure of Q1. So Q1 itself, then on Q1 on epsilon it is going to only Q2. See, there is no different like a return direction here. That's why I'm not adding Q0 here. Then epsilon closure of Q2, that Q2 itself, and we don't have any outgoing path here on epsilon. That's why it is only Q2 here. So this is finding epsilon closure. So we have another example here, simulating a simple thing like epsilon closure of Q naught itself. So Q naught, then you will get Q1, and then you'll get Q2 also. So epsilon closure of Q naught is Q naught, Q1, Q2, and epsilon closure of Q1 itself, then Q2. For Q2, we have only Q2. So that's it. It is very simple, like reaching any state using epsilon. Is nothing but the epsilon closure. Set of all those types of states, you're calling it as a epsilon closure. So while converting from NFA with epsilon to NFA, we're going to use this epsilon closure. Thank you.